and welcome to this session here. Let me just set it up over here. All right, so how are you all doing? Apologize for that slight delay. There were some issues at my end with the right microphone. I wanted to make sure that I select the right one so that all of you can hear me loud and clear. So welcome everyone. My name is Payal Tandon. I'm one of the co-founders of GMAT, and I'll be your host today in this webinar in which we'll talk about how is it that we can solve difficult permutation and combination questions correctly with confidence on the test. So let's hear from all of you first. Tell me, what is it that you face issues with when it comes to permutations and combinations? So I want to hear from you before I go into the details of this webinar and before I set stage for how is it exactly that we're going to go through this. And all right, so I'm looking at what you guys are saying here. Difficult. Okay, so the approach, how to proceed, to go through question stem under time, constraints, the approach, distribution specifically. Distribution, I'm not quite sure what you mean by that. When to use the right formula. Permutations mainly are my challenge, and how to identify whether a question is a permutation question or some other question. Not able to convert word statement into an equation. Okay, now one thing, that difference between arrangement and combination. Okay. Now, I do want to set the stage right to different approaches by different people. It gets confusing. I can understand that. Okay, so let me talk about what is it exactly, to what degree of difficulty do you need to prepare yourself to solve permutations and combination questions. So essentially, GMAT doesn't test you on uber complicated permutation and combination questions. I believe quite a few of you are used to the CAT format of the test and the CAT exam. The CAT exam probably has quite a bit of high difficulty level. GMAT is nowhere close to that. So that's one thing that you can be rest assured of. That being said, the questions on the GMAT will definitely confuse you if you don't have that 200% clarity in the concepts. Okay, just change the pen here. Okay, you really need to have that 200% level of conceptual clarity for you to be able to solve the questions that the GMAT throws at you. Okay, which is why you need to build from grounds up. Okay, you need to build from ground up so that you can solve those difficult questions, and that is what we're going to be doing in this session. Okay, now I know that quite a few of you said that you don't know when to apply what formula. Don't have to worry about that. Okay, one thing that I will tell you is that for you to solve GMAT questions on permutations and combination, what you have to master are these process skills. Okay, how many of you are aware of these process skills? If you're not, I'm going to share YouTube articles, YouTube course series in which we discuss each and every process skill in detail. And these skills are applicable across the board on all quant questions. And you start applying these skills on number properties questions, continue to apply them on algebra questions, word problem questions, geometry questions. By the time you get to those advanced topics in which you have permutation and combination probability type questions, okay, you will be able to apply all of these skills in order to achieve these aspects over here, in order to solve these questions with the utmost confidence. So the thing that I'm telling you is, PNC as a topic, permutation and combination as a topic, I know is really very fretted upon topic. People are scared about it just because of the issues that many of you have listed over here. There are different approaches. There are many formulas. Don't know when to apply those formulas. Now, all of these issues come about. The root cause behind all these issues is that you don't know how those formulas have been arrived at. You don't know why what is the basic underlying principle behind these different approaches. I mean, these approaches are not really different. They are all based on one solid foundation. And that is what I'm going to teach you, or I'm going to expose you to, because this topic cannot be taught within 1 hour. My goal over here is to teach you how is it that you can learn this topic and master this topic. Okay, so one thing is, as you proceed through these topics, okay, as you proceed through these topics, as you continue to apply these process skills, by the time you get to advanced topics questions, the permutation and combination questions and probability questions are nothing but more glorified word problems. Okay, and with word problems, what is the most important thing to do? You need to translate the word problems, you need to visualize the scenario, and then you need to apply the appropriate concept to solve those questions. Okay, that's the exact same thing that we are going to do on permutations and combinations. Okay, so one thing that I want to request all of you to do is that the formulas that you have, first of all, how many different formulas do you know? NCR, NPR, arrangement formula, selection formula, right? NCR is used for selection, and then you have the circular combinations and whatnot, right? I want you to keep those formulas on the side just for the sake of this session, that too only for the first half of this session, okay? In the beginning of this session, in the first part of the session, I don't want you to think about those formulas, okay? What I want you to do is, I want you to think only in terms of the information that's given to you, only in terms of, I want you to translate that information. I want you to translate that information. I want you to visualize that, and then I want you to solve the question. Okay, I don't want you to worry about any formulas at all, especially in the first part of the webinar. Okay, in the second part of the webinar, you will automatically see that you are transitioning. You have that level of understanding that you can transition to apply the form, to be able to apply those formulas with the confidence that you need. Okay, is this clear? Let's hear from you. Is this point clear? All right, let's I see some yeses here. Yes, ma'am. All right, sounds good. Okay, so for the first part of the session, no formulas at all. Okay, I don't want you to tell me that you applied the NCR or the NPR. No, not at all. I just want you to follow the basic first principles. All right, sounds good. So with this, and okay, there's another thing which I want to mention over here. As you read the question statement, okay, what I want you to do is, our main goal from reading the question statement is to formulate this objective equation. That's the equation that becomes our formula, really. Okay, once you form, and once you, the way to formulate that that objective equation is to figure out, is there things such as, is there repetition involved? Is it an arrangement or a selection? Are the scenarios different? I mean, these are the things that you have to extract from the question statement in order to formulate your objective equation, in order to formulate your objective equation and then plug in the values. When I say plug in the values, implement the values into that objective equation and then to calculate it. Okay, so you will understand all of this. This may seem like a very high level stuff, but as you start to solve these questions, and again, the beginning questions in this webinar is actually split into 3 parts. Okay, part 1, very basic questions. Okay, some of you may find them very easy, but what I want you to question yourself, what I want you to probe in the first part is, did you have any confusions whatsoever? Because the key thing is, if on easy questions you have even an iota of confusion that should I do this or should I do that, that is a very big sign that you don't have conceptual clarity, the level of conceptual clarity that you need to have. Okay, so part 1 is easy. I want you to question, am I absolutely confident in each and every step that I have done? Okay, part 2, we add a little bit complexity to it, but we are still on easier questions only. Okay, we are just teaching you how to approach such questions. Part 3 is where we start to solve difficult questions, and these questions are from OG Advanced book. Okay, so by default, these are 700 level questions. Okay, now this is where we start to apply the formulas, but those formulas actually come in very naturally. Okay, so that is what we're going to do in this session. Okay, now so again, last part of the session is where you're going to see difficult questions, and I believe there are 4 of these questions. Initial part over here about 7 questions here. They're going to be easier, but these are the questions that are going to set the stage, set your conceptual understanding and the process that you need to do by utilizing these process skills. That's what these questions are going to do. Okay, so now let's go ahead, start solving this question. And as soon as you get to an answer, put in the answer. And for everyone, I would say steer away from from peeking the answers here so that you don't get influenced. Because again, this is for you. You need to get that that confidence that you can solve this question correctly. Okay, go ahead. All right, so I can see that there's a split between 2 choices, and almost, I won't say an even split, but 1/3 of the students have selected choice B as the correct answer over here. 1/3 of the votes are here, and the remaining 2/3 are here, which means there is definitely some level of confusion. I mean, people who have selected, the correct answer is choice D, and I'm going to explain why that's the correct answer. But definitely there is some level of confusion over here. That's why people are not selecting the correct answer. Now, my question to those of you who've selected choice D is, are you guys absolutely confident of your approach? Okay, that's what I want you to make sure that you understand. Okay. Okay, so now we're going to solve this question one by one and step by step. Okay. Okay, here. Okay. A company plans to assign identification numbers to its employees. Each ID number is to consist of 4 digits from 0 to 9, inclusive 4 digits. So there are going to be 4 digits here from 0 to 9. What is my sample over here? 0 to 9, inclusive. So 0 is inclusive, 9 is also included in the list, which means the total of 10 elements here that I can select from. Except that, so I have a constraint over here, except that first digit cannot be 0, which means for the first digit, my options are 9 only, because 0 is not possible over here, right? For my second digit, I have 10 as option. Okay, for third digit, 10 as options. For fourth digit, 10 digits are possible. Okay, now, do I need to, in order to get to my 4 identification number, in order to get to my 4-digit identification number, do I need to fill in each of these spaces? The answer is yes, absolutely. And if I need to fill in each of these spaces, this means that I need to multiply each of these tasks. In a sense, I have 4 tasks here. Task 1 is to fill in the first place. Task 2 is to fill in the second space. Task 3 is to fill in the third space. And task 4 is to fill in the fourth space. And I need to do all of these tasks in order to formulate my identification number. So that's my objective equation, that I need to multiply each of these. Okay. Now, the second part is, so this is the first part. The second part is, what all options do I have? And which is where understanding of this visualizing what all digits are possible in each of the spaces is important. So my answer over here is 9,000. Okay. Now, Hemraj is absolutely right. Repetition is allowed. Now, how do we know that repetition is allowed? When it's not explicitly stated in the question statement, you would assume that repetition is allowed. Okay, and those are the inferences that you have to draw from the question statement, and that's where your process skill of inference comes into picture. So you're reading the question statement, you are translating that, you are drawing inferences, you're also visualizing information. What you're doing over here is what you've this task, that this activity that you've done here, that there are 4 spaces and what all are possible, what are the options for each of the spaces, that's your visualization. So there are 3 process skills that you've applied. The 4th process skill over here is you've applied the constraint. What's the constraint over here? The constraint is that first digit cannot be 0. From there, you get to the fact that this one only has 9 options and you get to 9,000. Okay. Now, for those of you who selected choice B, where did you falter? You faltered because you thought that each of these need to be different, that repetition is not allowed. That's why you selected choice B as the correct answer. Is that correct? How many of you selected choice B as the correct answer because you saw that there is this different over here and you translated this to mean that repetition is not allowed? Tell me, how many of you made that mistake? Quite a few of you. Do you understand now why that's not the case? And again, whenever you get, initially, what I want you to do is I want you to visualize, this is a long problem. So I don't want you to create all these 9,000 cases. But what I want you to do is, okay, I'm going to take up two. So what I'm going to do is, let's assume that, let me change the pen here. Let's assume 0, 1, 2 as the possible digits here. Okay, 0 is not allowed in the first place, right? So my options will be 2. For my second place, options will be 3. For my third place, options will be 3. So my correct answer is 18. What I'm going to do is I'm going to now write down all these 18 options, and I want you to see that each of these 18 options result in different identification numbers. Okay, so here we go. So 1, 0, 0, 1, 0, 1, 1, 0, 2. Okay, so again, bear with me, because again, for those of you, this level of clarity is absolutely required so that you understand the difference between the scenarios that exist. Okay, so these are my 9 cases. I can create similar cases here with 2 in the first place. And again, when you're getting your concept solidified, it's very important to work this out on your own so that you understand what is happening over here. Okay, all of these are unique identification numbers. Okay, look at this. There is repetition repetition is happening. You have 2 1s here, you have 3 1s here, another 2 1s, you have 2 2s here, 3 2s here. Repetition is allowed, but so over here, repetition is allowed, but what you're getting are all distinct IDs. Okay, that's the logic behind this. Okay. All right, so I hope that all of you understand this. And if this point is not clear right now, I want you to do this on your own. Okay, work it out with smaller set of numbers so that you can visualize and you can you can internalize what does it mean to have 10 options and whatnot. Okay, all right, so now let's go on to our next question over here. And again, a detailed solution, text-based solution is over here, so you can take a look at that. Now, this was a variation of one of the questions from GMAT, from one of the GMAT prep tests. I'm not sure which one. Okay. All right. So now this is the actual question from that test. So again, what I want you to realize is that you do get such easy questions on the actual test as well. The thing that, okay, PNC questions are always going to be difficult, that's not really the case. Again, this is an easy one. Okay. All right. So let's go ahead and solve this question. All right. So this question, let's solve this now. We're going to read this question, okay? And I know that some of you are a bit confused about what's the difference between this question and the previous one. We're going to identify that. Again, identification numbers. Each identification number is to consist of 4 different digits. Okay, that is the difference. Okay, from 0 to 9 inclusive. Again, same thing as the previous question, except that the first digit cannot be 0. How many different identification numbers are possible? So again, we have the same scenario here. 4 spaces. We need to multiply. We need to do each of the tasks. Now the options over here are 9 digits for the first one. Now, because the digit cannot be repeated, now you have only 9 options for the second place. Okay. Now, because the digits cannot be repeated, you only have 8 options. Why? Because you've used up 2 over here, right? So you only have 8 options. And for the last one, you only have 7 options, which is why the correct answer over here is 4536. Okay. So again, the thing is that as you read the question statement, you need to infer from that question statement that repetition is not allowed. Okay, that's something which you have to infer. And how are you inferring that? You're inferring that from this different digits information that's given to you over there, that you have to use different digits. Okay, rest, everything is the same as the previous one. You have the constraint, that 0 constraint for the first place, constraint for the first place. Okay, and for the first place, and then you need to visualize in order to formulate your objective equation. Okay, very straightforward. Okay, now if inclusive word is not mentioned, then we should not include 9. Absolutely, inclusive needs to be mentioned for you to include 9. Okay, but why do we have to multiply 9 twice if they have to be different? Very good question. Now, for the first place, you have 9 digits. Why? Because 0 is not possible. You have 1 all the way to 9. Okay. Now, but for the second space, what's happening is you have already used up one of the digits from 1 to 9. So that one would not be allowed. So 10 minus 1, okay, plus 0. Now 0 is an option. That's why you can utilize 0 over there. Okay, it's a good question. Okay, Nicholas, really good question. Why is it that you have 9 here and 9 here? Okay, so very nice. Okay, all right, so now let's move on to our next question. Okay, so again, you always have to think about what all possibilities do you have, what all options do you have. And again, don't worry about the formula. As long as you are utilizing, you're able to visualize the scenario from the question statement, you don't have to worry about formulas right now when you're building your conceptual understanding. Okay, formulas you would utilize once you have built your conceptual understanding. Formulas would come naturally. Okay, all right, so now again, if you, after the session, if you have any doubts, you can always go back to this presentation and you can look at the detailed text-based solution. Okay. All right. So again, you have to read the question statement to extract the necessary information that you require in order to create your objective equation. Okay. Now, before I actually, yeah, let's finish this section, and then I'm going to take a pulse of the class to see where they are at. So solve this question. Again, relatively simple question. I just want you to apply the process that we have been talking about. All right, let's solve this question. Again, as I said, very straightforward question. In how many ways can we form a three-letter password? Three-letter password. Again, as soon as I read three-letter password, I create three spaces. Using letters from the set A, B, C, D, E, and F, so there are a total of 6 possibilities over here, such that the last letter is a vowel. Now, how many vowels do I have? 1, 2. 2 vowels here. So, as I'm reading the question statement, I am formulating my information over here. I'm formulating my objective equation, okay? So one thing I know is that I need to multiply because I need to fill in each of the 3 spaces in order to formulate my 3-letter password. What all are my options? For the first one, I have 6 options, 6 letters to choose from. Second one also, I have 6 letters to choose from, okay? For the last one, I have only 2 letters to choose from. So my correct answer over here is 72, okay? Now, there are a couple of you who selected some other choice over here. Well, let's see. Now, almost everyone selected choice E. So that's good. Good. All right. Now, let's solve this one last question here in the first section, and then we'll move on to the next section. So go ahead. All right. I can see that all of you are converging to the correct answer, which is really good. Now, the only reason why I included this question over here was to give you that variety of an objective equation. So you have, so you have 3 letters. You have a password that can be either a 3-letter or a 4-letter. Now, when you have an or, this means that you have an option. Okay, what does that mean? You can either make a 3-letter password or you can make a 4-letter password, which means that you don't necessarily have to do both. Okay, that's why you have an addition sign here. Okay, again, a very important point to keep in mind whenever you're solving an objective equation. Are all the tasks required, or is only one of the tasks required? Okay, so it's one or the other over here. Either you're making a 3-letter password or you're making a 4-letter password, right? Now, for 3-letter password, we have the same constraint, 6 letters, last 2 will be vowels. Okay, so you have the same answer as before, 72. For this one over here, you have the you'll have 6 times 6 times 6 times 2. The correct answer over here is addition of the 2, which is 504. Okay, so I have a question. Even in the previous question, wouldn't choosing from a set imply no repetition? No, it doesn't. It doesn't imply no repetition. When I'm choosing, see, if it is no repetition, then if I am repeating, then over here, so if I'm not repeating, let's say repetition was not allowed, then my correct answer over here would have been 6. I would have to use only 5 over here. Okay. Likewise, over here, 6 and then 5 and then 4. Okay, so again, you have to keep in mind what are the constraints that you're working with. Okay, and again, what I would say is take a look at, solve this on your own, utilizing certain smaller subset. Okay, so that you can visualize this. And that's why if you go back to the working out that I did for those 3 digits 1 0 1 2, do that on your own. Okay, so that you can figure this out. Okay, all right. So what we have done till now is we looked at 4 very simple questions, okay? And what we saw was how we extracted information from the question statement to arrive at our objective equation. What you see over here are the objective equations, okay? How we saw that over here repetitions were allowed, that was implied that you can repeat, And over here, because it said different digits, you translated that to imply that repetitions are not allowed. Okay. Now, the same thing, and again, over here in these two examples, what we saw was the objective equation when there is an or in the question statement. Okay. All right. So now what we're going to do is we are going to enhance this a little bit. Okay. But till now, tell me, what have you learned? What have you learned about do you feel more comfortable with permutations and combination? I mean, just not worrying about the formula. Again, these are very basic questions, but are you feeling more confident about it? Good. All right. So if this is helping you, hit the like button. Okay. I know this is a good refresher. I'm glad that you're liking it. So that's really good. Hit the like button over there so that I can see from your likes as well that you're enjoying this. Okay. All right. So let's move on to our next segment. Now here, I want you to think about so we're going to discuss certain scenarios over here. Okay. Now in this case, what we saw was we were creating ID numbers wherein 1254 was different from 1452. Now again, both of these have same digits, right? You have 1, 2, 1, 4, 1, 2, 4, 5, right? Here also you have 1, 2, 4, 5, but their combinations are different, their placements are different, and that's why you have two different numbers there, right? So the same thing was in Q3, question number 3 and 4 as well. Passwords were different. ABC is different from CBA, right? So this is where you conclude that arrangement matters. It matters where you place these components on the spaces. Okay. Now, what if the final arrangement didn't matter? And this is where you have to arrangement versus selection. A couple of you were posing those questions. Is simply, are you fixing the place of the components that you are placing in these spaces, or are you simply picking those up and putting them in a bucket so that it doesn't matter where in the bucket they lie? That is the difference between arrangement and selection. And whether a problem is asking about arrangement or selection is something that you need to infer from the question statement. Another, again, inference process skill. Okay. So let's just take an example. In how many ways can we select we need to select 3 different letters out of ABC to form a 3-letter word? And the answer over here is in only one way. You have to select 3 different letters. ABC, they are the only 3 letters available. So there is only one way over there. Okay. Now, right now, let's say, now we can certainly, from those 3 letters, we can definitely form 6 different words. But the ways in which we can select those 3 letters is only one. Okay. So again, the arrangement of those 3 letters don't matter. So the cases that we would have gotten by doing the filling spaces method are the additional cases. Those cases we have to remove. We need to divide that. Okay. That's why what you have to do is when there is selection, and this is where the formula for selection comes about. Okay. I'm teaching you the derivation of that formula. Okay. Now you may not get it in this session. So I will share this presentation with you. Go through this again on your own, or all of this is explained in our PNC concept 1 in our course. So definitely review that concept file. Okay. So all the GMAT students over here, definitely go and review that concept file. Okay. All right. So now, yeah. So basically what you have to do is you have to, whatever you get by filling spaces method, you need to divide that number in order to get to the selection part. Okay. So we'll see one more variation here. In how many ways can we select 2 different letters? So 2 different letters out of A, B, and C to form a 2-letter word. Now, again, one thing that I want you to understand is in selection, it's always that you're selecting different letters, because it's the repetition is not allowed, is implied when you are selecting something. Do you see that? This is a very important point. When you're selecting something, repetition is not allowed is actually implied. Why is that? Because when you are choosing something, you've already selected that. You've already plucked that from the group, right? You've already put that. This is your universe and this is your bucket. You've already selected that and you've put that over here. So you cannot really select that thing again, right? So again, repetition is not allowed is something which is implied whenever you're working out a selection problem. I want you to understand this part. Okay. All right. So the correct answer is 3. Number of you selected that. That's good. Again, we can easily find the 6 words that will be formed. Those 6 words are, these are the 6 words. But again, there is AB is not a different selection than BA. So we need to divide that. Okay, and that's what we get. So what we are doing over here is we're simply doing total number of words divided by words formed using 2 letters. 6 divided by 2 factorial, and that is 3. Again, I want you to I'm not going into the details of this. I'm just skimming through this, but I want you to make sure that you have solid understanding of this part. But philosophically, conceptually, you have to visualize what is it that we are talking about, okay? And again, this point over here, the point that I wrote on the previous slide, that repetition is not allowed is implied when you're selecting something is very, very important. I want you to get to that level of understanding, okay? Now what we're going to do is, so again, the takeaway over here, if the arrangement does not matter, and again, this is something which you have to understand, infer from the question statement. Okay, whether selection is required or not, or whether arrangement is required or not, you need to infer that. So that is something which, as you're reading the question statement, you need to draw those inferences from the question statement. Okay, now once you figure out that arrangement is not required, then you divide the total cases obtained by the filling spaces method utilizing our objective equation by the total cases that are being multiplied additionally to get to the correct answer. So you need to do this division over there. Okay. Again, all of this is explained in detail in PNC Concept 1. Okay, so definitely review that. Okay. All right. Now, solve this question. This is also from the official GMAT test, a slight variation of it. So solve this question and then we will discuss. But again, as you're solving this question, I know it's going to be obvious. We just talked about selection. So over here also, there's going to be selection. It's obvious transition. But I want you to read the question statement and I want you to make sure that you can draw, you tell me from what part of the question statement you are understanding, you're inferring that this is a selection question and not an arrangement question. Okay? All right. Let's solve this question now. So I see that most of you have selected choice C. Joseph has selected choice D. Hemraj is not sure. Okay, all right. So let's solve this one. A certain university will select, now over here will select. So the question itself clarifies that it is selecting, that you have to select, okay? And if you think about it, okay, so a certain university will select one of seven candidates eligible to fill a position in the mathematics department. So you have mathematics department over here, okay, and there are 7 people, and out of whom we have to select one person, and 2 of 10 candidates, so 2 of 10 candidates eligible to fill 2 identical positions. Very important word over here, 2 identical positions in the computer science department. So computer science department, there are 2 identical positions, okay, 1 and 2, and there are 10 people, and 2 have to be selected over here. Okay, 2 have to be selected over here. All right. Now, if none of the candidates is eligible for a position in both departments, okay, so basically you have 7 over here are these 7 can only fill in here, these 10 can only fill in here. How many different sets of 3 candidates are there to fill in the 3 positions? Okay, so now how many people can you select from 7? How many people can go in over here? 7, right? There are 7 ways in selecting one person from this 7, right? Now, in how many ways can you select 2 people from these 10 people? And this is where you have to understand that, okay, for if you select, so let's do our filling spaces method over here. If you select 10 people, you have 10 options for this first position. Now you've already selected one person, right? So you cannot select that person again, right? So you have 9 options for that second position, okay? This is where I said that repetition is not allowed, is implied. Okay, nowhere in the question it says that repetition is allowed or not allowed, right? And so you may consider that, okay, repetition would be allowed because it's not specified. But the very fact that you're selecting people for a particular position, and once you select a person, you cannot select that person again for another position, implies that repetition is not allowed. So very, very important to understand that from the context of the question, from the scenario of the question, you have to visualize whether repetition is allowed or not. Okay, that's the first thing. The second thing is you've filled up these spaces, right? But over here, it doesn't matter who goes in the first spot and who, let's say you have A, B and B, A. These will be 2, these will formulate these 90 cases, right? But whether you select A, B or B, A, it's the same thing. Whether you select A first or A later, doesn't matter, which means that this is only a selection problem. So you need to divide this by 2 factorial over here to get to your correct answer. Okay, and the correct answer over here is 315. All right. So again, I am not using any formulas. Okay. Now again, if you are at that conceptual clarity, that level that you can utilize formula, you could have utilized NCR over here to calculate this thing for the computer science department, and that would have gotten you to here. But whether to apply NCR or NPR, okay, that requires you to understand what is the scenario that is given to you, okay, and which is why I don't want you to rely on formulas just yet till the time you don't understand how are these formulas coming into picture. Why are you doing this? Why do you have a 9 here and not a 10 here? Why is this wrong? Okay, what is the reasoning behind this? You need to understand that before you start to blindly apply NCR or NPR. Because students don't understand the logic behind these things, okay, because students don't understand the logic behind these things, that is why they end up being confused about what formula to apply when. Does this make sense? Because this is the crux of how you can master permutations and combinations. Okay, if you understand this crux, everything is going to come straightforward to you. Okay, all right. So is this point clear before I go forward with the next question? Okay, what is the difference between none of the candidates is eligible or not eligible for position in both departments? Again, over here, all this means is that these 7 people, once you select them, they are eligible only for this position. They are not eligible for this position. So it's just more of a clarification, nothing else. Why was 2 factorial used? For this very reason. For this very reason, that whether you select A first, let's say John, and Jack. These are two people selected, right? Now, whether you choose John first or Jack first doesn't matter. But if you're doing 10 times 9 over here, both the combinations exist. Okay. Jack also, these two exist as two separate combinations. And again, if you are still asking me that question, I want you to go back to the first question wherein I did the analysis of 0, 1, 2. Go back and watch that part of the video. Do that working out on your own with 2 digits, 3 digits, 4 digits, so that you can understand what all these combinations mean. Okay, where is the repetition? If you were to simply select, which ones would you remove from there? Okay, very, very important. Do that analysis on your own. Okay. All right. In CS department, if positions are different, why they set two identical positions? Hemraj, good question. Actually, let's get to that. These two positions, because that actually brings up another point over there. Let's say these are identical positions. And what am I doing from the understanding that these are identical positions? I am saying that I need to divide this by 2 factorial. Okay, this information that these are identical positions lead me to divide this by 2 factorial, because this tells me that this is a selection problem and not an arrangement problem. Okay, but because these are identical positions, so whether I select John first for that position or Jack first doesn't matter. But let's say if the positions were for the president, okay, let's say if the positions were for president and the vice president. Okay, now let's say I select John as the president and Jack as the vice president. In my second one, I may select Jack as the president and John as the vice president. Now, for John, this is a different assignment than this one. If John is the president, it's going to be different assignment than if John is the vice president. Okay. In this case, if these positions were not identical, in that case, this would have been an arrangement question. In which case, I would not have had to divide this by 2 factorial. Okay, so again, very important to understand. And that's where if you blindly see that, okay, you have to select and you blindly apply that NCR formula, you will end up getting wrong answer over here, because you will blindly divide this by 2 factorial. That's why it's very important to understand the logic behind these formulas over there. So very good question, Hemraj. And again, that's how I want you to question. As you are solving questions in PNC on your own, again, these questions are not uber difficult, right? They are very, very logical questions. But as you're solving these questions on your own, while you're building your ability, I want you to question such stuff. What part in the question statement is telling me, the steps that I'm doing over here, where am I getting that information from? How am I getting that information? What if this was different? What if it was that? That kind of analysis is very important. Okay. All right, then. Let's solve this question and yeah. All right. So again, straightforward question. But again, the reason why I have these easy questions over here is so that you know for sure how is it that you're applying the process here. Class A has 6 boys and 4 girls. Okay, so you have 6 boys and 4 girls in class A, 6 boys, 4 girls. Class B has 8 boys and 7 girls. In how many ways can a teacher select 2 boys? Now again, select 2 boys from class A and exactly 1 girl from class B. Okay, so it's very clear what you're selecting. Now again, here there is no question of you're selecting 2 boys, right? Now once you select a boy, you cannot select him again. So it's a pure scenario of selection thing. So you can apply your 6C 2 over here, your formula over here, and here you have 7C1. Okay, so here I'm simply applying the selection formula. And again, as I said, slowly I'm going to transition to selection formula, okay, to selection and permutation formulas, okay. But I want you to make sure that only after you understand all of this intricate stuff here, why do I have 10 times 9 here? Why is it not 10 times 10? Why do I have 2 factorial over here in the denominator? Only once you understand the basic components of the formula, only then you should think about applying the formula directly. Okay, so again, let's move on. The correct answer here is choice D, which is what everyone selected. So that's good. Let's move on to next question. Now this question is slight variation of the previous one. Let's solve this one. I know that not everyone has solved the question till now, and I can understand where you guys may be stuck at. Okay, people who got it are getting to the correct answer, but I know there are some of you who are stuck. Okay, so let me walk you through the solution. Okay, in a junior school, class A has 6 boys. So let's write down. Class A has 6, it's boys, girls. Class B has boys and girls here. So 6 boys and 4 girls, while class B has 8 boys and 7 girls. In how many ways can a teacher select exactly one student from each of the 2 classes? So you are selecting exactly one student, okay, from each of, sorry about that, yeah, from each of the 2 classes, such that to form a team of 1 boy and 1 girl. This is what 1 boy and 1 girl. Okay. Now, what does this mean? This means that there could be a scenario in which you select 1 boy from class A. So class A gives 1 boy, and which means that you would need 1 girl from class B. Okay. Or you could get 1 girl from class A and 1 boy from class B. Okay, so these are the 2 cases that exist. Okay, this is case 1 and this is case 2. So your objective equation, you have to consider, in your objective equation, you have to consider both these cases. Okay, so if you add these 2 cases. Okay, again, both these cases are not required to be done at the same time, right? It doesn't make sense, right? So what we have to do is we have to consider both these cases and in our objective equation, and again these will be multiplied and the product will be added. So the correct answer over here is how many ways you can select 1 boy From 6 boys, 6 ways. How many ways? So this 6 over here. How many ways can you select one girl from 7 girls over here? 7. Likewise, what do you get over here? 4 times 8. So the correct answer over here is 74. Okay, that's your correct answer over here. All right. So again, all you're doing over here is you are starting to apply the formula. What you're doing is NCR over here, or you're simply saying this is a simple thing. You have 6 people, you have to select one person, and how many ways can you do that? So either you apply the formula or you do the filling spaces method. It's exactly the same thing, but this is the most important thing wherein you are applying, you are utilizing the objective equation. Okay. All right. So now this is something which I have detailed slides on this, but I'm not going to be discussing these slides in detail. Again, you will get this in the PDF, which we're going to share after the session. But what I'm going to do is I'm going to solve this question. And through this question, I'm going to explain to you the concept. Okay, so that's what we're going to do. So let's solve this question now. All right. So let's solve this question. The correct answer here is choice C. 360 is the correct answer here. Okay. So let's try solving this question now. What does it say? It says that you have these letters C, I, R, C, L, E. Okay. Can be used to form 6-letter strings such that this and this, which means that over here you can repetition. So you have using these letters, how many different 6-letter strings can be formed. Okay, so what you have is that can use 6-letter strings such as this. Okay, so what you have is 1, 2. So again, over here you can see that repetition is not allowed over here, right? So you have these 6 spaces and you're using each letter over here, each individual letter over here only once. Okay, now let's take an example over here. When you see C and C here, right? So let's say you have, so which means first thing is, for the first spot you have 6, for the second spot you have 5, for the third you have 4, 3, 2, 1, okay? And you need to fill in each of these spaces, okay? Now again, how am I assuming that there is no repetition? Okay, that's something which you have to understand. Why am I assuming that repetition is not allowed? Tell me that. Tell me, what part of the information, what information is given to me in the question statement that allows me to draw this inference that repetition is not allowed? I'm going to wait for some responses and then I'm going to explain that to you, because this is the most important thing, okay? Calculation is the easiest thing, okay? So there are two things over here. Either I have 6 times 6 times 6, okay? Or, okay, let's see. Joseph is saying because of the example given. Yes and no, okay? Different words, not really. They have to be different words, no. You don't need to retract your message, Joseph. That's okay. Letters are given, certain number of letters are given. Absolutely right. Okay. Think about it. Okay. Think about it. Let's say I have these letters. So imagine, and this is where you need to visualize. Okay. Visualization is very, very important. If you master the visualization process skill, PNC questions will be very easy. Okay. Think about it. You visualize it. All of you have in some point in time played Scrabble, right? Okay, let's assume this is a game of Scrabble. You get these letters CIRULE, right? Now let's say you've used C letter once, okay? You cannot select that again. So you cannot select this instant, this tile, you cannot select again. Okay, likewise, let's say you've picked up R once from your tiles and you've put them on the board, right? Let's say you've put this R over here on the board. Now this R is already gone. You cannot select that again. Likewise, let's say you have picked up this L. This L is on the board. Now this L has disappeared. So the mere setup of the question is such that you cannot do repetition. Okay, now contrast this with the passwords that we were forming. Okay, where we were forming the passwords with, let's say, letters A, B, and C, there were no tiles. Those were just, these are just open, that's just given to you that these are the letters. Again, you can utilize them as many times as you need to. Okay, so again, you have to think about what in the question statement is leading you, is giving you information that repetition is not allowed. It's not that these are different 6-letter strings. Again, we've already talked about that. And I want you to go back. I want you to consider this question and the 0, 1, 2 question formulation that we did in question number 1. Contrast these two scenarios. Okay, very, very important. Okay. Yes, thank you, Sandeep. C, 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 where repetition is allowed. C, 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 L, 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 L. Again, repetition is allowed in both the cases, but they are still different. And that's why I want you to look at the discussion that we had on 0, 1, 2 numbers in question number 1. Okay, but again, the thing is, it's the scenario that you need to visualize. Here, think about these as separate tiles. Okay, once you use a tile, you cannot reuse it, which means repetition is by default not allowed, which is why you have 6 times 5 times 4 times 3 times 2 times 1. Okay, now once that part is clear, now what we have to think about is you have 2 C's. Okay, let's assume on the first board you wrote C. Okay, now on the second tile also happens to be C. Okay, now in this thing, the placement already it already considers, let's say, C1 C2 or C2 C1. So these two are considered as separate arrangements, which are already inbuilt into this product. And again, go back to this discussion over here so that you can understand why I'm saying what I'm saying. So what you have to do is you have to divide that by 2 factorial. 2 of the numbers are same, you need to divide that by 2 factorial. Okay? So that is why the correct answer over here is choice C. Is this point clear? Yes or no? Very, very simple. I mean, if you were to just memorize the formula, you would see, you would need to, again, if you were to do this purely from your formulaic understanding, what all things would need to fall in place? You would need to recollect, okay, what is the scenario in which if I have to select certain stuff and things repeat, and then I have to divide this? I mean, there's just so much of if then analysis that you have to do in order to just get that formula from your repository, versus if you understand the solid conceptual the stuff that we have talked about till this session, till this point in the session. If you simply get that level of clarity, you wouldn't have to worry about all those intricate formulas. Okay, now CKQ, you didn't understand the part about 2 factorial. What I want you to do is I want you to go back to my questions 5 and 6, in which we talk about the arrangement versus the selection. I want you to go through that part of the webinar. And again, my point here, it's not feasible for me to teach you all the stuff to the same level of, to have everyone get to the same level of clarity. But my goal was truly to tell you what it is that you need to do in order to get to that level of understanding. Okay, so I hope you guys understand. What I would strongly recommend is go through the permutations and combination concept files in the GMAT course. You will understand all of these things really very well. Okay. Okay. Thank you, Sandeep, for clarifying that. Okay, so now what we're going to do is, now this one is going to be slightly more advanced for certain people. If you haven't gotten question number 8, it's going to be difficult for you to solve question number 9. But let's solve this. And again, once you go through the module, you will be able to get all these things in detail. Okay, so let's go ahead and solve this question. All right. Okay, so now this is another question. The correct answer over here is choice B. And in this question also, what we are doing is we will be utilizing our visualize process skill. And I've shared this playlist with you. I would strongly urge all of you to go through this mini course that we have created on process skills. Okay, so definitely bookmark that. You will be able to figure out, and we are talking about, as I told you upfront, we are talking about PNC in the context of applying process skills, and how by applying these different process skills, you can solve even the most difficult questions on PNC, on GMAT. Okay, but I want you to build those process skills through the easier questions. I mean, through number properties, algebra, and so on and so forth. Okay, and that's why I go through this course on YouTube to get that solid understanding of these process skills. Okay, all right. So let's come back to this question over here. Similar question. But there is this extra constraint, okay? What's given is, using these letters, how many different 6-letter strings can be formed in which the 2 occurrences of letter C are separated by at least one other letter? Now, what does this mean? This means that, let's say, so 1, 2, 3, 4, 5, 6, 6 over here. Let's say you have C over here. So you need to separate it out by C. Another combination could be, I'm just going to write it under, let's say C, you could have 2 spaces, okay? Or maybe you start from here, you could have all these 4 spaces, or you could start from here, you have 2 spaces and you have this, right? So you can either write down each of these as separate combinations, and you create objective equations for each of these combinations, or you simply think about it. Okay, what do we not want? Over here, we don't want C and C to be together, okay? What if I calculate the total number of letters, the total number of words possible, and subtract from it all the words in which C and C are always together, okay? So I can do it that way as well. And this is where the visualization comes into picture. Okay, you need to visualize this as well. You need to first visualize what is the scenario that the question statement is presenting to you, and then from that scenario you infer the objective equation. Now your question is simply find the total number of ways, which you've already done, subtract all the ways in which C and C are together. Okay, now if C and C are to be together, you really can consider them as a single word, so single spot, okay, single character. So now instead of forming 6-letter words, what you have is you are combining these 2 together. So now you have a 5-letter word, 1, 2, 3, 4, 5, and the letters are C, C, I, R, L, and E, which means these can be formulated in 5 factorial. Your correct answer over here would be 360 minus 120, which is 240. Okay, again, detailed solution is given over here, text-based solution. So if you want to read through all the explanation, you can very well read through all the explanation and get to the correct answer. Okay, so let's solve this question now. Once you solve this, is the second last question of this session. I know we are way over the time limit, but I can see that all of you are fairly into the session, and let me hear from you a little bit as we are going into the difficult questions. Let's just, the question that you've been solving, the circle question, this is a difficult question as well. These are all from official guide advanced book, okay? But where do you think you are at right now? How do you feel right now? How do you feel right now? Do you feel more confident about permutation and combinations? Do you think this is something which you can master if you prepare using the right materials? How do you feel about the visualization that we talked about, drawing inferences? Does that seem, does that, do those, does this methodology make you feel more in control of permutation and combination as a topic? Nicholas is saying better than before. That's really good to know. And again, if you haven't as yet hit the like button, definitely do that, please, because that tells me that you're really getting the essence of this session. Are the previous questions less than 700 level questions? The previous question, let me just go back into my PPT over here. Question number 8 onwards have been 700 level questions. So question number 8, 9, 10, and 11, these are all 700 level questions. Okay. Improved confidence. I need some more materials on this. Again, look at the GMAT quant course. Not quite easy, but definitely there's an improvement. And again, yes, absolutely. The whole point, the whole reason why we are scared of PNC is because of all the formulas that are there, all the different scenarios that are there. What I want you to think about is, don't worry about the scenarios at all. Trust your skills, trust your process skills. And if you build these process skills from grounds up, you won't have to worry about all those scenarios. Okay. Personally hate formulas. Thank you, Rahman. I am absolutely of that opinion. I don't want to rely upon formulas. I want to make sure that I have that strong understanding. Why question that? Good. Thank you so much. I really appreciate all your responses here. Let's now come back to solving our 10th and 11th questions. Both these questions are pretty similar. So if you get 10th question, you will be able to get 11th question as well. Again, both of these are from I thought these are from official advanced book. Yeah, these are from official advanced book. So that could be incorrect, tag over there. All right, go ahead. GMAT course is not free. You'll have to purchase it. We do have some concept files that are in our free trial, so definitely take a look at them. But the PNC module is not free of charge. Okay. All right, go ahead, solve the question. All right, I have shared another link about when to add and when to multiply in PNC problems. So also bookmark that post. So definitely do that. All right. So let me see. Did I copy this? Oh, I didn't copy the right link. Sorry about that. All right. All right. I'm going to share that with you shortly because I think I ended up pasting the same link. So I'm going to share that with you in a bit. Okay. All right. So let's solve this. In the figure above, X and Y represent locations in a district of a certain city where the streets form a rectangular grid. Now, again, this image is given to you. Okay, so that's something which you don't need to visualize. You don't need to come up with this image from this statement. Okay, so which is a good thing. In traveling only north, so you can only go north. So even if you don't know your directions well, that's okay. You've been given a compass here, or east, or in this direction. So you can only go in this direction or in this direction along the streets from X to Y. How many different paths are possible? Okay, so one thing for sure is the way this information over here, traveling only north or east, are giving you the constraints. What this is telling you is that you can't be going like this and then deciding to go here and then here. All these paths, all this combination is not possible. You can either go here or here. Okay, now you can go here. You can decide to go up, here, here, here. All of that is fine, but you cannot really go zigzag. You cannot go back. You cannot come down. Okay, so all these, so this part is actually giving you the constraints so that you can visualize the problem well. Now, if you think about it, what's happening here? You go north, north, total of 3. You can go at most three times north. Okay, right? Let's say you decided to go here, east, one north. Again, you go east, another north, east, another north. Again, here also 3 norths, right? Likewise, there are only 1, 2, 3, 4, 5. You can go east only 5 times. And you can take another scenario. Let's say you go up here then you go here, right? Then you go up here, then you have to go 4 over here. There's no other combination there, right? Which means that there are total of 3 norths and total of 5 easts that are possible. Okay, so essentially you have to figure out how many different paths are possible. So for that, you need to figure out what are all the options there, right? So in a sense, you have converted your map problem into your string problem. Okay, that's what you have translated. Okay, you have translated your map into your string problem. Now all you have to do is you have to figure out how many different arrangements are possible. Now, how many spots are there? You have a total of 1, 2, 3, 4. You have a total of 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. Okay, you have a total of 8 spots, obviously, right? So over here, again, I'm going to use the formula here, but I want to make sure that you understand where that formula comes about from. And that is what we talked about in the circle question. Okay, so this over here, 8 factorial divided by 3 factorial divided by 5 factorial is the application of that circle question that we did. Okay, make sure that your concepts are solidified there. Once they are solidified there, you can solve these 700 level questions with utmost ease. But the main thing that you have to keep in mind is once you get that conceptual clarity, right? What you need to then focus on is how do you take this complex looking, map related question and how do you get it to this form over here? That is the skill that you need to master. That is the visualization skill that you need to work on. Okay. Does this make sense? Okay. Again, from formula standpoint, we are still working on our filling spaces method only. We are just adding a little bit of complexity, which we have already discussed. This is what we did in part 2 of this webinar, where we introduced certain complexities. Okay, the circle question, that is what we are applying over here. The concept that we applied there, that is what we are applying here. Okay, so again, I want you to understand what it is that you need to work on in order to do well on these questions. Okay, now what we're going to do is you solve this question. Again, similar question. What is just showing you a slightly different variety, and how do you infer, how do you read the question statement and get those different points about the question statement? Okay, so go ahead and solve this, and we are at the end of the session, almost at the end of the session. I must really give you guys kudos. You've been at it since the last 1.5 hours, and I can see the engagement really, really good. So carry on with it. Last question. All right, so we are at the end of this one. Last question, again, very similar question. This is OG Advanced book. Okay, I think this needs to be corrected. This is OG Advanced. Okay, all of you are arriving at the correct answer. 10 is the correct answer. Now, I want to make sure that you understand. Are you guys getting confident? As you solved this question, were you able to see the translation from the map or the visualization from the map to this kind of a problem, that you can either go, streets, there are 1, 2, 3 streets, and there are 2 avenues. Okay, so it's really just a string problem then. And now to solve this, what you have to do is 5 factorial divided by 3 factorial and 2 factorial. And again, I want you to recognize what I'm doing now is I'm not applying the basic principles to see whether I have to do 5 factorial or 3 factorial or 2 factorial. Now, as I have established my conceptual understanding, as I know where the 5 factorial comes from, where the 3 factorial comes from, now I can confidently, in the exam environment, my focus is going to be, how do I take this question statement and convert that into this problem? This is what the focus of my attention will be in the exam environment. And then this part is going to be simply a recollection of the formula which I have in my arsenal. Okay. That is the level that I want you to get at. I don't want you to be thinking, okay, first of all, I don't want you to get scared of, oh my goodness, this is a map thing. I haven't done this kind of a problem. I don't want you to be scared of that. Okay. I want you to trust yourself to be able to translate this in and visualize this problem into the string problem. That's the first thing. The second thing is, I want you to have that much level of confidence in, once you figure this out, this formula should be something which you get to right away. Okay. Good question, Prasanna. What do we do with the minimum possible? Very good question. Time pass, yes, that is interesting name there. Minimum possible length. Let's see. What if I go here, then I go here, then I go here, I go here, I go here, here, here. How many streets did I cross? 1, 2, 3. How many avenues? 1, 2, 3. Wait a minute. What am I doing here? Yeah, 1, 2, 3. And then here also street S, street, what, I'm doing something wrong there. Hold on. So if you go here, this is 1 street, this is 1 avenue, 2 streets, 2 avenues, 3 streets, 3 avenues. Then again, so if you go back and forth, then it's no longer minimum, which means if you're going back and forth, it's not, you don't have 3 streets and you don't have 2 avenues. You have way more than 3 streets and way more than 2 avenues. That is the significance of minimum possible. By minimum possible, you have to take the shortest distance. And for the shortest distance is you go straight, and then you go towards the avenues. The shortest is 3 streets and 2 avenues. Does this make sense? So again, good question. How do you figure out? And that is what goes into your translation of this question to be a string question with 3 S's and 2 A's. That is the information that takes you there. All right. So again, let's now recap everything. And I have been kind of recapping stuff as we have been going through this. So again, you have to be 200% confident with the concepts. You need to read and understand the question statement properly. Take your time to visualize the scenario. Visualize process skill, very, very important. Okay. And then formulate your equation. Your objective equation is very important, but finally the answer comes towards the end. And in terms of the concepts, I actually don't worry about, you know, the NCR, the NPR, and those kind of things. As long as you simply focus on what you are doing, where does the why is the NCR formula what it is? You know, if you understand the various components, you will be able to understand this really well. Okay. All right, then. And again, these are some, if you focus on the basic concepts, regardless of what level you're at, you will be able to get to the right ability level in quant. Again, whether you're an engineer background, non-engineering background, the main thing is your methodical approach for learning the concepts and not just mugging up the formula. Okay. All right. Thank you, Sandeep, for answering Biswajit's question. Maximum length will be infinite. You'll just keep going up and down. You will be trapped in your own loop. Okay, so you don't want to be there. You don't want to be in that position. And again, that's one thing which I want you to understand, that GMAT is not going to throw anything at you that you won't be able to solve. Okay, GMAT is a very logical exam. So I want you to trust the test maker. I want you to trust yourself. And you'll be able to trust yourself as you build these process skills. Okay. All right, then. Now, there were some of you who were asking me questions about, let me just share some links with you now. I know TimePass asked me about GMAT online. Would you advise it? Would you advise it, and how sooner should we take it for MBA applications fall 2021? I would say, my personal opinion, wait for the in-center exam. That's my personal opinion. But again, it's just way too many. If you're not applying in round 3 and 4, I would say hold off, take the in-center exam. There are just way too many variables in the at-home exam. You cannot take notes in a scratch pad. That's the biggest thing for me. And yeah, so I would say if you can wait, definitely wait for the in-center exam. Okay, but as such, how to take the new at-home exam, let me share this link. So you need to have all the information for yourself, right? So look at this link, I'm sharing it. That's one. Then let's say how to prepare for GMAT at home. All right, and again, the process skill video playlist, I'm going to share that once again with you. Definitely bookmark that and look at it. All right. So with this, we've come to the end of the session, and thank you so much. That really makes my day, Rahman. I'm not venturing into pronouncing your first name there, but yeah, thank you so much. That really makes my day. You know, it's my job here is to make sure that GMAT preparation is enjoyable for you. That's what we are here for. Okay. All right then. And again, if you haven't as yet hit the like button, definitely do so. I would really appreciate that. And Himraj, for the next webinar, again, you should check out the schedule that has been posted by GMAT Club. But as such, on the eGMAT platform, we conduct webinars every Saturday and Sunday. This Sunday, we have algebra webinar, so definitely register for that. So, you can register for an account on eGMAT, and you can then register for that webinar. All right, so thank you very much. Good luck, and definitely focus on working on your process skills. And TimePass, appreciate you being a student. Really appreciate that, and continue at it. If you have any questions about how to continue with your preparation, definitely write to us. We have a full GMAT strategy team on standby, waiting to guide you. Okay, so definitely send us an email. All right, then. Good luck. And yeah, let us know if you have any questions. Write to me at payal@e-gmat.com. Let me just post that as well. Any questions that you may have. Okay, bye-bye.